Hello, my name is Renato and I will present the work UAVs for Object Detection, Neural Networks to Analyze Onboard Computers' Energy Consumption and Temperature. The electric UAVs are being used in different sectors to perform different tasks, and one of the most common tasks is object detection, involving onboard computer. Two important factors for this type of mission are the autonomy of the UAVs and the temperature control of onboard computer. So for this work, we are going to use a Raspberry Pi 4 running detection modules from the YOLO family and MaskR CNN, and using neural networks make estimates of the computer's energy consumption and predictions of its temperature while using the models, with the objective of analyze the impacts of the energy consumption of the modules in relation to the UAV and prevent the computer from overheating during the mission. The first step is to configure the Raspberry Pi to run the detector modules, installing the necessary libraries and configuring your operating system. The next step was to extract the data that would be used to train the neural network, responsible for returning the estimated energy consumption. For this, temperature, CPU, and memory data provided by Raspberry were collected, and electric current using the USB meter. Data were collected while using the Raspberry in different tasks, from just being turned on to running detector models. 2,323 points were collected with a time space of 1 second. The next step was to design a multi-layer perception network to perform energy consumption estimates. For this, an exhaustive search was carried out among 1,089 different modules, changing the number of layers, neurons, and dropout. As can be seen, the best model found has 5 layers, with dropout of the first layer, having as input temperature and CPU data, and as an output the estimated electric current. In the next step, we extract the data in the form of a 30-minute flight simulation to create the processor temperature prediction model and perform future analysis of processor energy consumption and temperature. The simulations were made based on the Vant manufactured by DJI Phantom 4. Finally, the creation of an LSTM model to predict the temperature of the Raspberry processor, doing an exhaustive research by changing the topology of the model, where the best model is able to predict the temperature of the onboard computer 15 seconds in advance, based on previous 30 seconds. The results show that the energy consumption of the board running the detector models is between 3 and 4% of the consumption of the UAV, and the isolate consumption of the algorithms is between 39 and 49% of the consumption of the Raspberry. The estimate curves in red show how the model is able to accurately estimate the values of the electric current in black, obtain a mean square error of only 0.00054. The LSTM network was able to follow the trend of the real curves well, as illustrated in the figure, getting a mean square error of 0.56752, with 96.4% accuracy for predictions of 5 values above 70 degrees. We conclude that the multi-layer neural perception network proved to be very efficient to estimate the energy consumption of the onboard computer. The detector algorithm represents a low percent of the energy consumption in relation to the UAV, but to obtain the results of its consumption can represent a great control of autonomy during the mission. The LSTM network was able to predict the trend of overheating of the onboard computer very well. Such results are very relevant to avoid an overheating of the system during the mission, thus being able to prolong the life of the equipment and avoid previous damage to the equipment. The codes used in this work are available at the link below. Thank you for your attention.